Welcome everyone to our session on identifying unknown risks in your system. If you have any questions during this talk, definitely post it into the chat window this direction, and we will answer it at the end during the Q&A section. Okay, so as many of you might know, Alison and me are huge Star Wars fans, and let me share my screen while I'm talking so that you can actually see what I'm talking about.
The whole family affair at my house with Star Wars. The whole clan is in on it.
Nice. So then I have to ask you, Alison, have you seen the new series Ahsoka?
I've seen part of the new series. I got a delayed start because I wanted to go back and rewatch some Star Wars Rebels to just familiarize myself with the storyline. It'd been a little bit.
Nice, cool. So I didn't watch the Rebel series, but I could still follow Ahsoka. But I think you're definitely going to get more out of this series doing that. So for anyone not familiar, Ahsoka is a new Disney Star Wars series that takes place after the end of the original 3 movies, but before the new prequels. So it is right smack sandwich in between, and it's at the same time as Mandalorian, which takes place at the same time. Okay, so while I was watching Ahsoka, I was thinking back to our hyperspace navigation app that we built and showcased at PyCon US. And in our app, right, we've got lots of planet data. All the planets in the Star Wars galaxy is put into this graph, and they're all interconnected from their hyperspace lanes. So we built this plotting application. And so we've got all this great data in this database. So Alison, I was thinking while watching, without spoiling, that there is this big bad villain that shows up. And at this point in the series, the Empire has been more or less defeated, right? The Emperor is gone and the Rebel Alliance has become the Republic. So this big bad villain is introduced to come and try and put the Empire back together. So I was kind of curious, what is this villain going to do to take back the Empire, right? And can we make use of the data that we have now to highlight those rebel vulnerabilities for this villain to take advantage of?
Sure.
Okay,
yeah, go ahead. Sorry.
No. I was just going to say that from a developer standpoint, like conceptually, I understand what the problem is and what I'm trying to answer. And if I'm looking at planets on lane, I can kind of guess at what might be important. But trying to codify this turned out to be quite a bit of a challenge. So yeah, I wanted to ask you, what would you recommend be the best approach to solving this type of problem?
Yeah, great question, Jason. So, I mean, to your point, even just looking at this hyperspace navigator, it's not really clear. And in most of our graphs, we have the same kind of problem. There's so much data. How do we find out what's important? So, being your data science friend, I'm glad you asked, because what we want to look at in this case is we're going to take into account the idea of centrality. So what centrality means, if you want to hit the next slide, I'm sorry, we skipped over what data we have. My apologies. So Jason, you want to tell us a little bit about our data?
Yes. Yeah. So I kind of alluded to this. So the data that we have in this hyperspace navigator is really just a few node types, right? Primarily planets and the relationships between the planets, mainly their connections on the hyperspace lane. And then what side are they affiliated with, right? In this case, light side or the dark side or neutral. Okay. All right, Alison.
Thank you so much. I didn't want to skip that over. So when we're trying to find out the important node, we use different types of algorithms called centrality. And in our graph data science library, we have, 8 or 10 different centrality algorithms. And what do they actually do? What they do is they take a mathematical approach to the graph to figure out which nodes are important. And it could be, depending on which algorithm we're using, there's different things. It could be, do they have the most connections? Are they important across pathways? How many hops is it from one to another? So there's lots of different mathematical ways that we can actually approach your graph. Excuse me. Approach this graph, Jason. And so part of what we want to understand is, what do you think this dastardly villain might want to, what kind of an action might they want to take? Because depending on the action they want to take, different nodes might be more important.
Right. Okay. So I think there's two general approaches this villain can go for, right? Go for the Hollywood approach, which is, he has access to some super weapon and he's going for some like high value target someplace. The other option is he's more like a real general, right? Like Sherman, right? Going for logistical hubs that aren't going to be like really well-known places, but are logistically important, right? Like a really important Amazon warehouse, for example.
Yeah.
So I think these are two approaches that this villain can go for.
So let's start with the first one. I'm going to take you to the next page. And what I would recommend in that case, if we're trying to find a really influential planet, what we want to do is we're going to use an algorithm called PageRank. And what PageRank does is it qualifies a node as important if either A, many nodes link to it, and or important nodes linked to it. So if we go to the next slide, I'll walk you through a little bit of sort of a toy example of how this works. So let's say this is what our network looks like, and you and each of your friends each have $1. And these arrows, the edges in your graph, show the flow. Now, in this scenario, we're going to play a game where everybody starts with $1. And what they need to do is they take what they have and they put it to any of their outgoing nodes. So for example, in this upper middle, we see there's a single node and there's 3 coming in and only 1 going out. So in that case, that person is going to send their whole $1 down to this lower right, and it's going to collect from those other 3 nodes. So let's go to the next slide and say, after the first iteration, what does that look like? Well, in the upper right, the person only had $1 and it went one way. And so they've given away all their money. And then we can see on the lower right-hand corner, just under the 0, we see a 2 because that person started with $1 and there's no outgoing mechanism. And there's 1 incoming, so that person's whole amount came to them. And so this is roughly the way that PageRank is working, is that it's continually redistributing until it finds a balance. So let's go to the next slide. So in the next iteration, it would look like this. And so a couple of things to note here is that when we look at the original structure, we may have thought that this upper middle was the most important because it had 3 incoming connections, 1 outgoing connection. And so here we're seeing lots of connections. However, the other aspect is and important nodes connect to it. So in this case, we've got 1 node, and this important node here at the top is sending all of its weight to this single node. So in PageRank, what we're really looking to do is we're really looking to understand which of the nodes are important based on connection and whether or not an important connection connects to it. An interesting thing to note here at the bottom is we've got these 2 nodes that are both connected to each other. That 33 cents is just going to keep going back and forth between them, and that's very stable. So eventually PageRank just gets to, after a certain number of iterations, gets to stability. And so this is one way that I would recommend you can calculate the importance of something that's influential, because here we see that that top middle and that lower right are the most influential based on PageRank.
Okay, and in our case, since we're not tracking economy inside our data set, so this is tracking pathways, right? Like where certain ships and fleets can pass through what systems, and so it's kind of like
exactly
transportation PageRank value.
Yeah, okay. In a lot of ways, that's a really good way of looking at it, because, here we're looking at influence. It could be, maybe it's a market flow of, imports and exports. There's any number of values that could be driving these connections, but it's this mechanism underneath that allows you to use this type of approach for calculating importance.
Okay, so this looks like the best way of calculating where our villain should deploy like a super weapon, right?
Yes, for sure.
Awesome. So would just looking at this, would PageRank also be applicable for the other scenario where he's going for kind of logistical centers?
No. And the reason is, if we look even at this map, let's just say this giant one on the lower right, we take it out. it's not changing the majority of that supply chain, right? All those other connections still exist. By taking out that one, we're only taking out one connection. So it's going to have a minimal effect on supply chain if we think of these as pathways. So in that case, what I would say, let's go to the next slide and I'll tell you about a different type of centrality. We have something called betweenness centrality. And it's probably easiest to explain with the visual that we have. But in short, it says a node is important if a large number of shortest paths pass through it. So let's head to the next slide and I'll show you what I mean. So when we say shortest path, in this case, we're saying if I took the shortest path between any combination of two nodes, right? And then I say for each node in the graph, how many of the shortest paths pass through it? So what we're going to see here is that I like to think of it sort of as, let's just say you've got a major city and then you have an island, right? And there's important things happening on both, right? Maybe you've got two major hubs, and in PageRank, there was like a central point in each. So let's just say the central point in, on the right-hand side in blue, it would be B, and we see the center point on the right. So if we were doing PageRank, those would probably be the nodes that came forward as being important. But in this case, what we see with betweenness is that if we took out A, all of a sudden, there's no connection of any kind between any of the red nodes and any of the blue nodes. So what that means is that it's a really a critical point. Yeah, good comment. In the chat. So thank you, Tobias. So really what we're saying is in this case, it would be like taking out the bridge between the city and the island. So betweenness centrality allows us to find vulnerabilities that there aren't a lot of connections, right? There's one on each side. So a traditional, say you had an RDBMS, it doesn't have a lot of things connected to it. It seems kind of unimportant. But we see actually that it's really critical. So if you're looking at logistics, you're looking at flows, you're trying to interrupt some kind of flow, then this algorithm of betweenness is really going to give you what you're looking for. So to your point, if we're trying to if we're the bad guys and we're trying to upset the rebels getting their X-wings where they need to go, you're definitely going to want to use betweenness centrality for understanding where your target should be.
Excellent. Okay. So okay. So now we've got these two different methods of determining, some high profile targets for our
a lot of math.
So yes. So my next question as a developer, right? So this all conceptually makes sense, is how do I deploy this? How do I implement this in an application?
Got it. So if we go to the next slide, I can walk you through how we did this. So we have the Graph Data Science plugin at Neo4j. I use it with the Python driver. And in the rough way that it works is we take the base graph and we create something called a projection. And in a projection, all that we're doing is we're taking a graph. In our connections. You'll recall from our data model that we also had an affiliation, whether they were light side or dark side. But when we're talking about pathways, it's not a pathway, so we don't want to include that. Then what we do is we actually use the driver to run the algorithm. And what's great about GDS is the amount of code that you need is very minimal. You create the projection and you run the algorithm. Within Neo4j, you can what we call stream the algorithm, which allows you to just look at the outputs and give it a sniff test and say, does this make sense? And then what I used was the write aspect, which writes directly back to the database. So I ran the betweenness algorithm. I ran the PageRank algorithm on just the planets and the next two relationships. And I wrote those to the database to make them available to my friendly developer who's working hard to expand this navigation system.
Nice, thank you. So once you've done this, I basically got two extra properties for every node now available, right? I've got a page ranked and a betweenness property. And the value I get is a float. Higher the float, the higher it's ranked in both categories. Okay, so now that I've got these both, now I can key off of that, right? I can use that to change the visual mapping or use it as a filter. Many, many options. But before I go in and actually add this to my application, I really kind of want to check this out. I want to test it, right? So we've got a couple of options for looking at this data. One is using Bloom or the browser. But recently I've been enjoying using NeoDash, and I'll bring this up. So NeoDash is a kind of a widget dashboard, right? So you can create these little widgets that shows data, like a snippet of data from the actual underlying graph database. So what I'm going to do is I'm just going to spin this up real quick and see. All right, so I managed to break this earlier. Okay, so when you first start up NeoDash, you basically get a blank canvas. There's usually an instruction widget here, which I deleted. Okay, so when doing this, you can just go right in and start writing Cypher to query things, right? So I could, just get all the planets, or maybe actually I'll just return just the count, right, of all the planets that we have. Ooh, well, this would be more than
all the nodes.
All the nodes, right? So let's see, this give us a single number, which is probably least interesting, but
single value.
An option for
just go up a little bit. There should be single value. There you go.
Cool. All right. So I've got 2,000 planets in my system, right? Okay. So if you know Cypher, this is great. You can, add all these widgets and get a sense of what data, and you can practice or test out your Cypher statements here before moving it into an applications driver. Now, this feature was added earlier this year. I really love this one, is this natural language query function. So what this does is it basically runs your description through OpenAI, and it will return a Cypher statement that matches, will attempt to match with your data set. So what's happening under the hood is the implementation is looking at your database schema, pulling that schema up, and basically training part of the LLM with that. I believe it's prompt engineering or prompt stuffing with that. But the effect is it's able to create a Cypher query based on your, or in this case, our graph data schema or graph data model schema. Okay. All right. So once you first do that, you'll be asked to put your OpenAI key, which I've already done. So what I'm going to do here is I'm just going to ask it like the question I'm wanting to answer from this, right? Which is, which are the most important planets? Which planets are the most important?
How many planets do you want, Jason? All the planets?
Yeah. Let's talk about this. Let's what are the top 10 most important planets? Ooh. And if our connection is good, it should only take a few moments. All right, so this is the Cypher statement it gave us, which is pretty good. So it knew to take PageRank, and it's using PageRank to sort with. So let's see what that looks like. And here we go. So here are the planets, and I can't see the affiliation here. So it's just out of picture. Or is it not populated?
I'm not sure.
I know why. So the affiliation, so there isn't an affiliation property, right? Because what we've done is, so here I'll modify the Cypher statement here, right? So optional match the planet and
has affiliation.
Has affiliation. So we use this. And then what do we call this? Like a side?
Yeah, I think it's actually just affiliation is the label type.
Is it? Okay, I think this will work. So if I just do S and then S name, was that the property?
That'll do it.
Affiliation. Okay, so here, update that, and maybe I just don't have enough space. Is that the problem?
Yep, could be.
Could be. Here, let me delete this guy. Let's see, make some more room. Doop. Oh, you can do half-size widgets. Okay. All right. Well.
So point being, NeoDash is a great way to go through and take a look at which are, what might be that data, what that data might look like right now, and is it passing what we believe our sniff test should be?
Yes. Okay, so I think probably got the, I can clear this. So what I'm bringing up here is the Neo4j browser, and what I'm going to do is just check, has affiliation. Oh, you know what? No, I suspect I'm misspelling something somewhere. Right. Anyways, okay, I won't dwell on this too much. But anyways, so yeah, NeoDash, you can experiment with cipher statements. And once I'm happy with the query, I can add that to my application here. And so here's the original hyperspace navigator, displays all the planets. And I've added in color coding for those that are most affiliated with the Empire, those being red, and those being with the light side or the rebels being blue. And at the bottom, I've added a dropdown for give me the most important planets based on, I believe, PageRank is what I chose here, PageRank or betweenness. So here I made 3 different categories. One for the most important in general, which all ended up being mostly neutral except for Endor, and then which were most important to the rebels and which were most important to the Empire at the time of the final movie, right? The Battle of Endor.
Yep.
So yeah, so updating the app was super quick after you had updated the properties with the betweenness and the PageRank data.
Yeah, I mean, sorry to just butt in, but I think one of the things that's most interesting to me about Centrality is oftentimes when, you've been with Neo4j a while, you've got your original use case, but I think it's worth folks just taking a moment and thinking about what are the graphs that they're currently working with, what that might look like, and start to ask yourselves, what could I discern if I understood importance or centrality in my particular instance? So if we think back to, COVID and super spreaders, right? Super spreaders definitely have an importance, and there was a lot of connections to those, right? If we have a number of folks who, use Neo4j for tracking network traffic and hardware and things like that. And so taking the time to really see, where is that betweenness? Do I have a potential high impact critical failure point that I may or may not be aware of because I haven't looked at it in this manner? So the idea of why we wanted to talk about identifying this unknown risk is because it allows you to look at your system and take actions to improve the viability of what you have. So if you have something that's high betweenness, start finding some additional pathways around or some backup systems. If you've got really influential points, do you have the appropriate security on those points? So just some things to start thinking about. I don't know, we have so many different ways that people use Neo4j, but I think what's really important is to just really start to see yourself in your graph in what we're talking about.
Nice, good stuff. All right, so what I've put up here is, this is our link of links. So this will have links to the repo, the code repo that I have for the navigation app that I demonstrated, also some resources and our contact info. One thing that I just realized is the cloud instance of the app is, I believe, not running at the moment. But more importantly, if you want to run this data, we need to make actually this database and the data set available. So that's something, Alison, I think we should probably go ahead and export the data and maybe put it up in Kaggle.
So we're in the repo. We'll have the collab available as well as the data sets that we use so that you can play with it yourself. Hey, Jason, can I just point out one other thing that I kind of noticed as it went by? When you showed your NeoDash example, one of the things that you had run here on the right-hand side where it says the shortest path algorithm. This particular shortest path algorithm actually includes affiliation between those two planets. And so, sometimes people say, well, why do I need to do a projection in order to run an algorithm? And it's really just because the graph itself, everything's connected, right? So I may be a planet that has a connection to the light side, and another planet is also connected to the light side, but I can't actually pass through a place called light side to get to that other planet. So that's why we have to create that projection or that subgraph that just says, yes, these are the actual pathways. This is what we have. So it's just something that I noticed that came up, and I was just like, oh, let me see. I just wanted to point that out, because sometimes people wonder, what do we need to do a projection for in that graph data science step? Oh. Yeah.
Let's see. Okay, so I just, while you were talking, I put in to ask, what is the shortest path between Dathomir and Lothal, which, am I spelling this right? Next to, but okay, I think it's probably more than 10 hops, which is the issue. How many hops? Do 20? Let's see, return nodes. Let's see if this will run. It does. Okay. So I chose 2 planets.
In this case, we actually do have, this one happened to be just planets, but it is possible theoretically that maybe it had, like in Jason's example that he'd been playing with before, that it actually included like an affiliation. So point being, you just want to make sure that the reason why you're doing that projection is you have just the nodes that you need and just the appropriate relationships when you're running that algorithm.
Yes. I think what it's doing is next to planet. It's because of this.
Because we're using next to. If we made it any relationship, yeah, there you go.
Oh, yep. Of course that didn't work. Let's just do that. My cipher today is not good. All right, I guess I do.
Live deving. That's how it goes, right?
Relationships path as connections. Can I put this back in? Star 20. Sorry, I'm working with a very tiny
If anybody
window.
has any questions, you can feel free to drop them in the chat. We've got a few more questions left here at the end that perfect, Jason. I love this. So here we see Tatooine is neutral. And then there's a connection between the planets themselves, and then we go through the light side. So this is not in the real world a physical pathway that you could actually take. So this is the reason why on that GDS slide, we talk about doing the projection. It's a way of saying only include these types of nodes and relationships, right? So, the reason why it didn't come up before is Jason had noted in the cipher, it had automatically said only use next to, and that's another way of doing that. So, yes, there's a question on NeoDash. NeoDash is working depending on the cipher query only, or can we do any other to create the dashboard? So in NeoDash right now, you have the option to either use cipher or use the natural language, which, as we saw, takes your, there's that little toggle right there under type and database between cipher and English. So if you're not sure what the cipher should look like, you can type it in English and it'll give you a sample of the cipher. And, if you're somewhat familiar with cipher, you can certainly go in and edit at that point. And I love this tool. I just think it's such a great way to really easily take a look at what's in your graph and, do some of the EDA. It's my data scientist, my inner data scientist is showing when I'm looking to do exploratory data analysis of the graph. So big fan of NeoDash. So do we have any other questions?
Gata asked another one. He was asking, how can we identify the most important nodes, how it's depending on, and how can we display particular bits, IDs, I'm assuming? I think maybe this was asked before I showed this. So one option would be to just show a list, which is the simplest. Another would be to highlight it visually, right? So like I've got here, I've got certain nodes that are bigger than others and they're colored. So what I'll probably do is add in a filter, like show me the most important rebel planets and then have it visually shown, right? So I'm just taking that underlying kind of list data and converting into like a visual format to kind of just highlight it on this map. And the data actually could be used as part of the plotting algorithm, right? So I could add a feature here, which is like, avoid major Imperial hotspots or include major rebel points, to refuel, restock, that sort of stuff. So once, just having those extra properties generated by the graph data science gives this app way more options than I had previously.
Yeah. I would just want to point out that you'll see a ticker at the top asking you, do you have a question for Emil, our fearless leader of our own, our own, I don't know, affiliation, as it were, definitely the light side. So if you have any questions for Emil, you can certainly click on the scrolling banner at the top. He's going to be joining us shortly today. And I guess, like, really, Jason, this is episode 2, right? We started out just building the navigation, and now it's episode 2. I think you might be on point for episode 3 of once we get going in this galaxy, how do we avoid those nasty Empire planets? Could be a good one.
I'm excited for the next one.
Excellent.
Cool.
All righty.
Right,
We are at time. Thank you all so much for being with us today. If you have any questions, you can always reach us. Take a peek. We'll provide you with the collab, the link to the Streamlit app, and the data sets. And we look forward to seeing you in our graphs sometime soon. Bye, all.